Have you ever wondered about the universe's secrets but felt you were running short on time? Picture this: everything you've ever known, the history, life, and even time itself, all started from a point smaller than an atom. And guess what? You're a part of this mind-bending cosmic story. Let's embark on a roller coaster ride through the universe, and don't worry, we'll make it quick. Welcome to this summary of the book Astrophysics for People in a Hurry, by Neil De Grasse Tyson, one of the world's most renowned astrophysicists. Please subscribe to the channel, and if you like the video, please share it with your friends. Let's begin. The Big Bang. The author takes us back, way back nearly 14 billion years ago, to the very inception of our universe. Imagine, if you will, a single point, a singularity, infinitesimally small, hot, and dense. This is where our cosmic story begins. In a mere fraction of a second, this point expands explosively, giving birth to matter, energy, space, and time. The universe, as we know it, is set into motion. Tyson does a remarkable job of distilling this complicated process. He explains this wasn't an explosion in the traditional sense, like a bomb going off in pre-existing space. No, the Big Bang was the simultaneous appearance of space everywhere, expanding rapidly. It's like inflating a balloon, except this balloon is all there is. And what's fueling this rapid expansion? Initially, it was the intense heat and energy of the singularity itself. But as the universe cooled, matter began to form. Stars ignited, galaxies spiraled, and the universe took the shape we recognize today. So, the Big Bang is not just an event, but an ongoing process. The universe continues to expand, and humans are the product of cosmic history, a part of this grand, expansive narrative. Understanding the Big Bang is more than just comprehending our universe's past. It's about understanding our place in this ever-expanding cosmic tapestry. Dark matter and dark energy. These cosmic mysteries have puzzled scientists for decades. Let's start with dark matter. Imagine a galaxy, its stars swirling in a beautiful cosmic dance. But here's the catch: based on the gravitational pull we can measure, there isn't enough visible matter to keep that galaxy together. That's where dark matter comes into play. This invisible, undetectable matter provides the extra gravitational glue holding galaxies together. It doesn't interact with light, making it invisible and mysterious, yet its presence is undeniable. Now, onto dark energy. Picture the universe not just holding its shape, but expanding acceleratedly. Is the force driving this expansion? That's dark energy. Unlike dark matter, which clumps and helps form structure, dark energy seems to work in opposition, pushing things apart. Imagine dark matter as the rubber band that pulls the universe together and dark energy as the hands pulling the rubber band apart. These concepts are so intriguing because, collectively, dark matter and dark energy comprise about 95% of the universe. Yet, we know so little about them. They are the cosmic enigmas waiting to be unlocked. Let's embrace these uncertainties, for they fuel the quest for knowledge. Tyson encourages us to keep probing, questioning, and exploring because that's how we grow. Dark matter and dark energy may be elusive, but understanding them is vital to unlocking the whole narrative of our universe. They remind us that the cosmos is more mysterious and fascinating than we can comprehend. Exoplanets and alien life. One of the most exhilarating ideas Neil De Grasse Tyson explores is the concept of exoplanets and the tantalizing possibility of alien life. This notion captures our collective imagination like no other. Who hasn't looked at the night sky and wondered, are we alone? Let's start with what exoplanets are. The term exoplanet refers to any planet that orbits a star outside our solar system. With advancements in technology, specifically telescopes like the Kepler Space Telescope, we have identified thousands of these celestial bodies. Each discovery fuels the ongoing debate: could life be elsewhere in the universe? Scientists use fascinating methods to detect these planets. One popular technique is the transit method, where a planet passes in front of its host star, causing a temporary dimming of the star's light. Another method is the radial velocity or wobble method, where the planet's gravitational pull causes its star to wobble slightly. Many of these exoplanets are in what's known as the habitable zone, or more poetically, the Goldilocks zone, where conditions might be just right for life as we understand it. This zone allows for liquid water, a critical ingredient for life. One critical point to remember is our bias towards carbon-based life. What if life exists in forms we can't even fathom? Silicon-based life forms? Methane-breathing organisms? The possibilities are as limitless as our imagination. Remember that our galaxy contains over 100 billion stars, and the known universe harbors some 100 billion galaxies. The latest estimates suggest as many as 40 billion Earth-like planets in the Milky Way alone. The search for exoplanets and alien life embodies the curiosity and wonder that drives science. Whether we find other life forms or not, it's a quest that ultimately teaches us more about ourselves and our universe. Relativity and space-time. When it comes to understanding the framework of our universe, few concepts have been as transformative as Albert Einstein's theories of relativity. Neil De Grasse Tyson delves into this mind-bending area of physics, making it accessible for all. Einstein's general theory of relativity takes the concept of gravity and flips it on its head. Forget that objects like the Earth and the Sun pull on each other through an invisible force. Instead, imagine the universe as a 4D fabric called space-time. Massive objects, like stars and planets, warp this fabric. So when Earth orbits the Sun, it's not being pulled, it's following the natural curvature of the warped space-time around the Sun. What happens when matter is so dense that it warps space-time to an extreme? Enter black holes. These cosmic phenomena are the ultimate example of relativity in action. Their gravitational pull is so strong that no light can escape, making them the universe's ultimate trapdoors. The theory of general relativity was mind-blowing, but it gained concrete affirmation by discovering gravitational waves. When massive bodies like black holes or neutron stars collide, they send ripples through space-time, gravitational waves. The 2015 detection of these waves opened a new chapter in astronomy, allowing us to hear the universe in a whole new way. Relativity and space-time aren't just abstract scientific concepts, they're fundamental to our understanding of the universe and have practical implications for Earth. This awe and wonder make the pursuit of astrophysics so incredibly fulfilling. Astrophysics for People in a Hurry is a must-read for anyone curious about the cosmos. Tyson's ability to simplify complex concepts and engaging writing style makes this book a fascinating and accessible journey through the universe. Grab a copy of Astrophysics for People in a Hurry and start your journey through the cosmos today. Remember, we do not simply live in the universe. The universe lives within us. Neil De Grasse Tyson. We would love to hear your thoughts and insights on the fascinating concepts discussed in this video. Please leave a comment below and join the conversation. Thanks for watching. Hit the subscribe button, turn on the notification bell, and share this video with your friends and loved ones. Until next time, keep looking up.